Analytical, geometry. Right. Ilula leshandisi. Ama-marks amaningi afana paper 2 uyakwazi ngayo. Uyabona nje?
Ngiyabona.
Now, definitely understand what is a coordinate. A coordinate really is a point in 2D having x and y value given as this x given in the x comma y, which is x is 2y. So this is a coordinate, right? Now you can do a lot here, and you can expect you can transform a coordinate, you can reflect a coordinate, you can translate a coordinate. Understand? So this is the purpose of a coordinate, right? So e.g. 1 is to 2 and 3 is to minus 5. These are coordinates. This is the x value, this is the y value. This is the x value, this is the y value. This x value here is positive, this y value here is negative. One thing that you need to notice is you can always read a coordinate. You read the quadrant from the given coordinate. Since this one, if you are given 1 is to 2, both x and y are what? Are positive, which means this thing lies on the first quadrant. You can read it. Now if you have a 3 is to negative 5, y, the x is positive, the y is what? Is negative. Where is x positive? This side. Where is y negative? This side, which means a point lies there, which is the fourth quadrant. So you can read a coordinate and tell what quadrant they lie. Understand? So that is the purpose of a coordinate. Now, what do we use it for? Let's look at the distance. The distance. Now we have three types of distances. The first one, it's the horizontal. Horizontal. The second one, it's the vertical, and the last one, it's inclination, or we say it's at an angle theta, which means the distance that's at an angle theta, which is oblique. Understand? Right. How do we calculate horizontal distance? Now let us given the following. Let us look at the following. Let's look at the following first. I am going to draw a Cartesian plane. I'm going to draw a Cartesian plane. We can agree that is y, that is x, right? And then I'm going to give points. Let us say we have this distance here, right? And we'll say that point there, it is just a let's just say this is coordinate A, which is -4, is to 5, right? And then this point here, I'm going to call it B, which is 2, 3 is to 5. What do you notice about the horizontal line? You notice that the horizontal line, the y values, not the y values, the y coordinates does not change at all. The only thing that changes is what? It's the x-axis. The x-axis changes. Understand? Now, in this case, if the x-axis changes, there is a maximum x-axis and there is a minimum x-axis. Right? Now, one more thing about a horizontal line. Horizontal. What you need to notice about the horizontal line is this. The x coordinate changes, the y coordinate remain the same, which means it was 5 is going to be 5. If the x-axis changes, if the x coordinate changes, then there is a minimum x and a maximum x coordinate. Understand? If is that so again, it means if a line is horizontal, the y coordinate remains. It means this line is perpendicular to the y-axis and parallel to the x-axis. This information in Neo-Analytical, it's the most important info, because in an exam they'll just tell you this line is parallel to the x-axis. If a line is parallel to the x-axis, which means it's horizontal, the y changes, the y coordinate remains. The only thing that changes is the what? It is going to the x. Right? How do we calculate the distance? How do you calculate the distance? So distance between, well, how do you write it? Between 10, the coordinate. The distance between the coordinates is very simple, which means if you have that AB there, we will say that AB is going to be what? X maximum minus X minimum. Your X maximum, it's your X coordinate, which is the leftmost X coordinate, at the rightmost. This is the B is your rightmost X coordinate. A is your leftmost X coordinate. So if B is the rightmost X coordinate, so it's going to be the what? The X maximum. So to calculate that distance, AB, I'm going to say what? I'm going to say it's 3 minus, the formula contains a minus. What is the X coordinate of A? It's 4, it's negative 4, so I'm going to say it's minus 4. So distance AB is just equals to 7 units. 7 units. So now, key thing, the distance will never be negative. Time will never be negative. Volume can. Just know that volume can be negative. But distance and time and speed, or speed can be negative. But distance and time can never be negative. So that's why we contain a positive value there. If we are not given that this thing is measured in centimeters, you're always going to write units. You understand? So we are done with the horizontal. So if you are given that, if you are told that a line is perpendicular here, then if you are told that a line is perpendicular to your y-axis, then this line is going to be what? It's going to be parallel to your x-axis. So that coordinate there, you can assume that coordinate, right? The y-coordinate does not change. X coordinate at the y-axis u1, u0, y-coordinate below line 1, 5. So that point of intersection there is what? Is 0 is to 5. You understand? Let's look at another line. Let's say this is P, this is Q. It is going to be negative 4. It's going to be negative 4 is to negative 1. It's going to be negative 4 is to 8. Now, the next one, it's the vertical distance. How do we calculate the vertical? So, vertical. Now, in a vertical distance, what you need to know, it's the same thing, really. The x-coordinate, now, because the line up it's vertical like this, your x-coordinate does not what? Does not change. The only thing that changes is what? It's the y-coordinate. So, the x-coordinate does not change, but the y-coordinate changes. If it's that so, how can we find? So if this is the case, now because the x coordinate does not change, it means now we have a y maximum and a y minimum. So now we have a y maximum and a y minimum, right? Minimum, we have got a y minimum. Now, how can you see a y minimum? How can you see a y maximum? A y maximum, it's the topest y coordinate. So which topest y coordinate do you have, lad? It's going to be p, which is what? It's going to be 8, right? And your minimum, it's going to be the bottom, what? Y coordinate, which is going to be 1 or negative 1, right? So if that is the case, this line is going to be parallel to what? To the y-axis and perpendicular to the what? To the x-axis. The line is perpendicular to the x-axis and parallel to the y-axis. Now you can really see from here, this line here is just parallel to this line there. And this line here, it's going to be perpendicular to the x-axis. So you can determine that coordinates there. That coordinate, your x value does not change, right? Which is going to be what? Minus 4 is to what? Is to 0, because the y coordinates, the axis is always 1, always 0. You see? So we can calculate the distance. So PQ, normal QP, PQ or QP. How do we calculate a distance? It's y maximum minus y minimum, which is going to give us y maximum. Your y maximum is going to be 8 minus on the formula in bracket your y minimum, it was what? -1. And then punch this in the calculator, you're going to have 9 units. 9 units. See? Very easy. Very easy. Now, both horizontal and vertical, we call them, both of them, we call them both horizontal and vertical are 1-d distances. They are 1d distances. Why we call them 1d distances? To calculate that distance, we only use one coordinate, which is the y, normal band, or x. That's why we call them 1d distances. Now let's just look at the oblique, or at an angle distance. I'm going to draw a new y coordinate, the new Cartesian plane here. Right, and I'm going to substitute two distances. Two distances there. Right. Don't know what type of them, but let me just name them at the end. Let's check that is SR, and then this is going to be VP. Let's say UV wako is going to be -5:2, and then UP wako is going to be 1:3, like that, -3. US wako abo -5:5 represents R wako abo 4:8. Now, can I draw another Cartesian plane and discuss what will be the distance? Now, looking at that, let me remove this. Right, let us draw any distance, just like that. Any distance, any straight line, and then call it that distance is A, that coordinate is A, that coordinate is what? It's B. Now we know what line it's going to be X, Y. Again, la panels over X, Y. But you need to choose for yourself, because these x's are not the same, right? So I'll just call this one x1 and then call that one x2. If this one is x1, so this will be what? Y1, and that one will be what? Y2. Because these x coordinates are not the same. I cannot just say x1 x. I need to make it different. But okay, this x is x1, that x is what? Is x2. This y is y1, that y is y2, because these y's are not the same. Understand? Now, they make an angle theta. This straight line make an angle theta, which is the gradient. Theta is just the gradient, but you'd get there. How do you calculate this distance? Very, very easy. Now, because we have different x values, which is x2 minus x1, we can calculate it is a horizontal distance between x2 and x1, right? Which means, let me just say this, it's the x coordinate, that the x coordinate there. So a coordinate lapha, and I'm just going to call it P. This is a right angle triangle. I just made a right angle triangle. Now, the coordinate is going to be x2 is to y1. Can you agree with that? x2 y1. How can we calculate this distance? Very easy. Distance ka AP. If distance ka AP is over x2 minus x1, right? Which means it's going to be x2 minus x1. So it's calculated distance ka AP. We can calculate the distance ka foot ka P. The distance ka PP over. Distance ka PP is over y2 minus y1. So it's a distance. So it's a distance. Now, the distance ka ule. Distance. I need to write in a triangle. So if I let distance, so when they're in theorem of Pythagoras. Since the theorem of Pythagoras is what AB squared is equals to 1. AP squared and plus B P squared. But in asifuna AP yet, is a square root on both sides. Should see 8 distance ka AP yet to it's the square root of AP squared plus BP squared. But we are mazu AP wa kuti distance ka AP over x2 minus x1. So lapana is over the square root ska x2 minus x1 squared plus the distance ka BP over y2 minus y1. y2 minus y1 squared. So we say always to calculate the distance formula, which is oblique, we're always going to use that formula because it's the only formula that you can use to calculate our distance, which are oblique. Understand? So how can we calculate that distance? Think it's over the class now. So, how can we calculate the distance that is arc? Very simple. Uzosho when x1 low or y1 no uzosho point to y1. It does not matter. Now to calculate the distance that the distance given SR. So it's SR. So the opposite SR is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Right? And then substitute ubawazo menza x1. Now you're always going to, for me, if you learn akushonele nabo x1, if you learn akushonele nabo x1, so asenze labo x1 senze labo bani x2. So s wako coordinate ka s wako it's -5:5 and -5:5, and then a coordinate ka r it's going to be 4:8 and r is 4:8. So let's say 1 lava 2. So substitute x2 wako 4 minus 5 all of squared, right? Plus y2 wako it's 8 minus 5 all squared. That's how. Then calculate the distance, which is going to be, if you are going to use a calculator, 4 plus 5 squared plus 8 plus 5. if uzoyiphanja le nto kwi-calculator, I think uzoba 81 squared plus 69 squared. Sorry, it's not squared. The distance to SR, it's going to be 1.5 to 10 units. If you answer we exam, leave it like this. Right? E distance of VP. Sorry. VP. 18 corners V, it's negative 2, it's negative 5 is to 2. The distance got P1 for 1 is to negative 5. 1 is to negative. How can you calculate the distance of VP? Very easy. VP is equal to in the square root x2 minus x1 squared plus y2 minus y1 squared. VP is equal to x2 bakho sithe laba x1 bakho ilapha and then x2 ilapha, noma ungathi x1 laba noma ungathi x2 laba or x1 lapha, the answer is still the same. X2 wakho laphana ubani 1 minus 5, that's good, plus y2 wakho it's minus 5 and minus 2 all squared. Just calculate it. Yebo. That's sorry, and then punch that to your calculator. 1 plus 5 all squared plus negative 5 minus 2 all squared. Your answer is going to be root 85 units. So you can really see how can we calculate the distance. Now, anything I understood. Do you know how to find the equation of a straight line? Yes. Let us revise that. So let me just draw another Cartesian plane. Because ngizokhuluma ngoline emvakala, so you need to understand what is going on. How to find the equation of a straight line. I think you remember from functions, we are still using the same principle. We are still using the same principles. We are still using the same principle. Yes. So yeah. Let us just revise. How do we find the equation of a straight line? Let's say we have a straight line there, and that coordinate there. Let's just call this coordinates A, which is 2 is to 2. Coordinates B, which is equals to minus 4 is to minus 6. Like that. And then S, which is going to be negative 8 is to 7. I know it does not make sense, but this is not drawn to scale. Not drawn to scale. Just drawing. And there's an R here, which is going to be 2 is to negative 4. you know this is going to be y, that is going to be x, right? Now let us find the equation of a straight line. Now to find the equation of a straight line, really, first of all, let us find the equation AB. What will be the equation of AB? Now to find the equation of a straight line, AB, this thing is very easy. First, definitely peg lapha AB is what? It is your gradient, right? So as it's in gradient yakuban, which is equals to m, and it's the change in y over the change in x, which is y2 minus y1 over x2 minus x1. Now, ubani y2 wakho, you are going to choose for yourself. This is y2 or that is y2. But you can see with this line, UBA, it's from bottom left to top right, so it's an increasing graph. If there is an increasing graph, the current definitely be positive. So la panel 2 minus 6 over 2 minus 4. And then what will be the gradient? Punch that in your calculator. 2 plus 6 over 2 plus 4, which is going to be 4 over 3. Positive, yeah, answer that. Another thing that you need to notice, nothing will line also neck gradient so the line tends to approach the x-axis. It tends to approach the x-axis. The angle le izobancane compared to kunaliya angle. You understand? That angle there is going to be bigger than that angle. So now we can find the equation for straight line on it. So it's going to be y minus y1 is equals to m x minus x1. Yeah, this is the formula to find the equation. Y. Choose any coordinate la. Which one is this coordinate and substitute it la, or you're going to use that coordinate. We do not care. But at the end of the day, we need to have any equation for equation of a straight line. So I'm going to use this one. Minus 2 is equals to that one. It's 4 over 3 times x minus 2. And then simplify. So 4 over 3x minus 8 over 3. Now total of 4 over 3 multiply no 2 negative 4 over 3. Total of 2 low negative no plus 2. So your equation of a straight line like panels y is equals to 4 over 3x, which is equals to minus 8 over 3 plus 2 is over minus 2 over 3. Does it make sense? The diagram does not make sense. The diagram does not make sense because the coordinate in negative. That's what the straight line is circular. Understand? I said the diagrams are not drawn to scale. This one, it's the y-intercept. Now let us find the equation of SR. To find the equation by SR, what I will do, you'll tell a gradient by SR. Another thing that you need to know, whenever you are going to find the coordinate, always substitute the subscript MAP, MSR to specify. This is the gradient for only one for SR. So, each gradient, the change in y over the change in x, which is y2 minus y1 over x2 minus x1. I do not care which the x coordinate that you are going to use. It's minus 4 minus 2 divided by 2, minus 4 minus 2, and then 2 plus minus 8. Now what will be the gradient of minus 4 minus 2 over 2 plus 8, which is going to be negative 3 over 5. So that is the gradient given. So we can find the equation of a straight line. I'm going to use a different approach to find this gradient, to find this equation. I'm going to use y is equals to mx plus c. You can use both of these equations to find the equation of a straight line. Now, choose a coordinate here. Choose s or negative 8 or choose this one. Does not matter. What I'll do, I'm going to choose r. Uy wakho lapha aroba or negative 4. I'm going to substitute in negative 4. Gradient is Aruban, it's negative 3 over 5. What is the associated x coordinate of negative 4? It's 2 plus c, and then solve for c. C it's going to be negative 4 plus 6 over 5, which is negative 14 over 5. So the equation of these three lines are SR is over y is equal to gradient corner is minus 3 over 5, x corner is minus 14 over 5. Okay. You understand? So that is the equation. This is how we find the equation of a straight line. Understand? Right. Any question? Any question? Right. Let us look at the angle of inclination. The angle of inclination is given by the tangent of theta is equals to n. The tangent of theta is equals to n. That is the angle of inclination. I'm just going to say this is just grade 11 work. That is the angle of inclination. But this one was just grade 10, just revising how we calculated this. So to find the angle of inclination, really, you want a gradient. Now, let us use these two lines to find the angle of inclination of these two straight lines, right? So let's say tan theta for AB. Let us find the angle of inclination for AB. To find the angle of inclination for AB, it's going to be what? Tan theta is equal to 4 over 3. Now 4 over 3. And then to find the theta lapano, I'm just going to say theta is equal to the arctangent 4 over 3. Theta is going to be 53.13. That is the angle of inclination, AP, which means low line, the angle low line, lapano ban, you're 53.13 degrees, right? And then for SR, tan theta is over negative 3 over 5. Now, since this thing is negative, now aside from the angle, now SR ain't. The angle is aside from the angle is it's this angle. That one. So, we will calculate theta laphan. Theta wako la usuzothi 180 degrees minus the arctangent of 3 over 5, because lana njani negative. If it was positive, it's just tan 4 over 3 theta. So it's 180 degrees minus arctangent 3 over 5. So the theta wako la 3 over 4. It's going to be 180 minus arctangent 3 over 5, which is going to be 149.036 degrees. Now, another thing, the reason we round off into 3 decimal places, your first value here is 0. If your first value there is 0, you round off to 3 decimal places. But if your first value is a number, not 0, you round off to 2 decimal places. Any questions? Go back. Right. So this is how we calculate the inclination. Sometimes, let me just say this. When m is 1, then theta is 45 degrees. So that is a special case, which is totally current straight line current that when you want should see angle of inclination about the axis is U1 you 45 degrees. So I hope I understand. Right. Thing on gradient. on gradient. You know, on gradient, parallel lines will have equal gradient. Parallel lines will have an equal gradient. And perpendicular lines have a product of their gradient to be negative. So m1 times m2 must give you 1 negative 1. This case will only apply for perpendicular lines, right? But parallel lines, because they are parallel, they'll continue equal value. If all line back so or so, it does not matter. They will still have equal gradient. Understand? Now this case, this one, we are going to use it a lot. You'll see must send some questions. That case there is one of the important questions must when they analytical geometry, analyzing your diagrams in an exam. How can we say that is true? And sometimes you need to prove that these lines are perpendicular, these lines are parallel. To prove that a line is parallel or perpendicular, you need to find the gradients. To prove that the lines are perpendicular or a line bisects one another, you use the gradient. Right. Let us look at the concept here. The words. Oh, not something like the words. The terminologies. Yeah. Terminologies. I had them right in the terminology, but you can see it. Terminologies. The terminology, the first word that you need to understand here, it is the word called bisect. The meaning of the word bisect. Now, given line AB, I'm just going to give you line AB. Now, it's a line like that, it's a line like that, it's a line like that, but it's going to be line OAB. It's going to be line AB. When I say a line bisect OAB, it means a line cuts in half OAB, which means OAB will be divided into two. Let's just call that point C, which means if distance AC is equal to distance CB, right? And then if a line cuts OAB let's call it C, should the distance AC still is a line distance BC. If a line bisect OAB, it means this side is equal to this side, or we can just represent it by two decimal points. So it means cut in half. And cutting in half at what angle? At most cases, when a line bisects at an angle of 90 degrees, which means the line AB is going to be bisected by 90 degrees, by the 90 degrees, by the 90 degrees, unless a line is a latitude. Understand? Let's look at the next word. Latitude. Latitude. What is a latitude? It is the longest line in a triangle. Longest middle line in a triangle bisecting the base. Understand? Just draw a triangle. P Q R P Q R P Q R. It's the same thing, different ways. Now, what would be the latitude? La, that will bisect to AP. It's going to be a line from there to there, which means R, S. OSR is the latitude of this triangle. If Kamala Q is a bisect, I'm applying PR, which means it's going to be there to that. Now this line, it can be bisecting at 90 degrees, and it can be bisecting at an angle less than 90 degrees. But the purpose will be bisecting this line. So here will be equal to that. And then from P to that, just call it S. So this line there equals to that line there. So it's going to bisect. So a latitude is the longest middle line in a triangle bisecting the base. It's going to start from a particular point, go to the particular base and bisect it. It can be at 90 degrees, it can be less than 90 degrees. That is a latitude. Now, most of you do not know what is a latitude. I've noticed over the years, if a line from there to there bisect this line, that is a latitude. It's the height of this triangle coming from R. And the height from R to Q, it's not the same from the height from Q to this distance. It's not the same from there to there. But it is the height at the end of the day. It is the height. Right, it's going to be the height. It's going to be the height. So it's the word bisect, latitude. We have covered parallel and perpendicular. What is the next one? Transformation. Transformations. I know Catholic and I'm saying it's long. Transformations. But if that's nice, so like when I practice Biak, that's in 20 extra, I'll have it. If you're going to repeat this, trust me. Is we excel you can let's get geometry. Enjoy your opinion. Now the geometry of transformation. This was a standalone topic when you were in your mother's hand, like from 2012, 2011, or saying Ghana, this is going on a 2014 period is going. 2018. That's when you gave me transformations. In grade 12, this topic was there. It was a different topic. Because previously we had a paper out remits. Paper 1, paper 2, paper 3. Sure. Before 2014 was a figure caps. We have 3 papers in it. And if geometric transformation came in all of those papers, it was one of those topics. It is easy. Now the first one is called the translation. How to translate an object. Now, but we are not going to transform an object here. We are going to transform a coordinate. Let's look at the translation. Translation. I'm going to give you a coordinate which is going to be x is to y. Now, the first operation in translation is to translate left or right. Left or right. Now, transforming a coordinate left or right, you are going to effect the x coordinate only. I think you have noticed from here. If I'm transforming this coordinate today, I need to add +7 to give you 1 for 3, which means I'm effecting coordinates A to give me 1 for B, which means I have transformed the coordinates A 7 units to the right. Now, when transforming left and right, we only affect the x coordinate. Right, let's look at an example. Let's look at the example la, and the example is to the right by 7 units. If we transform this coordinates a to the right by 7 units, should nothing give no x plus 7 comma 1. This is no longer a, it's going to be what much a prime, because it's a new point of band a, right? And if I transform to the left by h units, should ngizothina laphana x minus band minus h comma y. Because I've transformed a single point again, I'm just going to call it a double prime, because in seconds is the same point. So I'm going to have a prime not to the left, to the right, and a double prime if I have a to the left. So whenever we're going to transform this thing left and right, we only affect the x coordinate. Alright, and then transforming up and down, we only affect the what? Guess. The y coordinate. Now this thing will also help you with my functions. My basic graph yako is shifted 2 units up, which means you're only going to effectively work QPL because you're shifting the graph upwards. So if you are doing an example, if nangeti to the mangeti nje upwards by 3 units. The same coordinates a, I'm going to have band x plus y plus 3, which is going to be a prime. And then if I get it downwards by p units, should I pronounce one no x comma y minus p a double. You understand? All downward is minus, upward is plus. All left it's minus, all right it's positive. See? Very easy. This is only translation. What about reflection? Now, to reflect something about a line, you need its distance, which is the horizontal distance. You understand? I'm just going to make an example here. Let's say this is your x numbers, and then you say this is a line, x is equals to 3. And then we have a coordinate now, x is equal to minus 3. And we have a coordinate that a is equals to 4:6. Negative 4:6. To reflect the point about this line, we calculate its distance from la to la. You understand? And then calculating its distance from la to la, you can calculate its distance from la to that new point, because its distance from la, need distance of what? Of reflection. A reflection is that easy. And if you are reflecting about a certain line, calculate the distance about that line and transpose it to the other side, it will be reflective. If you are going to reflect it about the y-axis, use the y-axis as a reference and then transform. If you are reflecting about the x-axis, use the x-axis as the reference and transform. If you can notice, if you are reflecting about the vertical line, you are only touching the x coordinate, because the y coordinate, the x coordinates distance in between is going to change, but the y still to remain the same. If you're reflecting about the x-axis, you are shifting this thing up, forward, or down. It's the same thing. If you are, I don't think a rotation they teach you, man. If you're rotating, you need an angle theta and rotate it around. So we need to use a polar coordinates to do that. So I don't think a rotation will be taught. It's been taught nowadays. But a rotation will need a particular angle. You need to know clockwise movement and anti-clockwise movement, and then do the calculations. But this will be the geometry of transformation. A translation, and I'm going to teach you translation. Maybe to reflect, use the translation. You're still going to have the same answer. But understand, Kuti, you are reflecting about what? If they are going to give you a segment, reflects this coordinate about this line. Very easy. Very easy. If they say reflect about a particular point, you are doomed. Because that is a no joke thing. But it's easy, because if you're reflecting about a point, let's say, I'm going to give an example here. Let's say you have point A, which is 2:3. And then I just say this is a point P, which is 4:6. Reflect a little point about this point, which means when I've calculated distance from this to there, and then from there to there, done. It's all about translation. All of these play around the translation. Right. What is the information? The basic info about analytical geometry. What is the basic intro? The areas. How to calculate the area of a particular polygon. I'm just going to give you the few areas, because badelela my exam. Now the area of a square, the area of a square, its length times length, right? The area of a cycle, it's pi r squared, and the area of a trapezium, I don't know how to write trapezium, it's going to be h over 2 times a plus b. Now these two are pair of parallel lines. Now do you see what trapezium is? That is a trapezium. A trapezium, something like this. There's only one pair of parallel side, this side and that side. This is going to be A, this is going to be B. You can say this is A, this is B, or this is going to be A, does not matter. And this H shades the perpendicular distance A, right? So the area of a trapezium, and the area of a kite, it's going to be A is equals to 1 over 2 d1 times d2. Now a kite yakime, so that is a kite. That is a kite. That is a kite. This side is equal to that side, this side is equal to that side. To calculate that area, you need this diagonal, you need also the diagonal. So you can just call this longest one d1 and this short one d2. And the last one, the area of a parallelogram. The area of the parallelogram is but I think it's the same thing as that. It's the same thing as that. Because the height and this distance is the same. So if you are going to use the same formula to calculate the area of a polygon. The area of a rectangle is the same, everything. But I think this is analytical geometry at the nutshell. Bye-bye.